Good day. We're going to continue our look at right triangles now by taking a look at the three main trigonometric functions. These are sine, cosine, and tangent. Each of these is a ratio of two side lengths in the triangle. So sine is opposite over hypotenuse, cosine of the angle is adjacent over hypotenuse, and the tangent of the angle is the opposite side divided by the adjacent side length. Here's the right triangle to which we will refer. You can see that we're using lowercase letters for the side lengths and uppercase letters for the angles. In addition, the side opposite the angle will have the same letter name. So side B is opposite angle B, and so on. Once again, the hypotenuse or longest side of the triangle will be opposite the right angle and is labeled C. Okay, so let's get started. In the first examples we will be determining the length of the side indicated. We're going to be rounding our answers to the nearest tenth. Let's begin with this example. We have 25 degrees for angle A, and side length A is 12. So I'm going to begin by labeling these on the triangle. Angle A, side A. We're going to try to determine side B. So I will label that as well. You can see now there are three things labeled on the triangle, and I've done this labeling by referring to this general triangle here. Now the objective is to correctly choose the trig function. For this angle, these side lengths are opposite and adjacent. Opposite and adjacent. And so that means we should choose tangent. So the tangent of 25 degrees is equal to the opposite side length, which is 12, divided by the adjacent side length, which is B. We now want to rearrange this so that B is isolated. So first we do our cross multiplication. So B multiplied by the tangent of 25 degrees is 12. And now we change from multiplication to division in isolating B. So B is 12 divided by the tangent of 25 degrees. Okay, so now we're going to use our calculator to obtain our answer. So you can watch the display. We're going to do 12 divided by tangent 25. You can see the D here on the display. This means I'm in degrees. And just push equals. And now we round this answer to the nearest tenth, and so that means it is 25.7 degrees. Okay, just like that. And now we're going to go ahead and look at our second example. Once again, we're given angle A. So that's the lower angle in the triangle. We're given side C this time, and that of course is the hypotenuse. Which side length are we trying to find? A, which is here. So now I'm going to choose the trig function that relates these three things. For this angle, this side is opposite, and this one of course is the hypotenuse. So we choose sine because that involves the opposite side length and the hypotenuse. So we write the sine of 32 degrees is, now we put the opposite side length in the top, which is A, and the hypotenuse under it. So that's 31. Now we rearrange so that A is isolated. All we have to do is multiply 31 times the sine of 32 degrees in order to obtain A. Okay, so changing from division by 31 to multiplication by 31. And then again, clear your calculator. 31 times the sine of 32 is, and we get our answer. And rounding to the nearest tenth, this will be 16.4. Okay, I'm just noticing a mistake in the previous question. I put a degree sign here. Of course, that's an error because we are finding side length. So in example A, we found side length B. So there should be no unit here. Okay, and similarly then in example B, we found side length A. There will be no degree sign when you're finding the side lengths. So sorry for any confusion there. Okay, let's continue with our next example. So here we go. This time we're given angle B. Now that is this upper angle here. We're also given side length B, which is the lower side. And again, I'm choosing that because of the general triangle. You see, B is up here, side B is down here. We're trying to find side C, so I'll label that there. Now, take a look at the angle. What is this side called? This would be called opposite. This side is opposite the angle. So we've got an opposite side length and the hypotenuse. So that means choosing sine. So the sine of 63 degrees is equal to 11 divided by C. Now we isolate C. First we multiply. C times the sine of 63 degrees is 11. Then we divide. C is 11 divided by the sine of 63 degrees. And now we use our calculator to get our answer, and we will round to the 10th. So 11 divided by the sine of 63. Okay, and this is 12.3. So C is approximately 12.3 units long. Okay, let's try D. So angle B is up here. Side C is the hypotenuse. We want to find side A, and remember that that's the vertical side. Okay, so now for this angle, what do we call these side lengths? This side is next to or adjacent to the angle. So we have an adjacent side and a hypotenuse is given. So which trig function uses an adjacent side and a hypotenuse? Cosine. Okay, so we will write the cosine of 5 degrees is, now we'll put the adjacent side over the hypotenuse like this. Solving for side A will require us to multiply. So we take 63 and we multiply it by the cosine of 5 degrees. 63. So the multiplication sign now is optional. So we could just do 63 cos 5 if we like to get our answer. And you can say we could also do 63 multiplied by the cosine of 5 and get the same answer. Okay, so this side length is 62.8 units in length. Okay, I've rounded to 1 decimal place, which is the nearest tenth. So the 7 rounds up because of the 6 beside it. Okay, awesome. I'm also going to do an example from your textbook, a word problem, and it is on page 229. So let me get that in our display. We're going to look at question 10. All right, let's read the problem. So here's the diagram. It says a furnace, here's the furnace, 6 feet wide and 4.5 feet high is placed in an attic with the front side vertically in line with the roof apex shown in this figure. The gabled roof has an incline of 22 degrees and covers a width span of 36 feet. What is the clearance? D, so D is labeled here. So we're trying to find this length D between the top back edge of the furnace and the roof. Okay, so that's a lot of language, but luckily they've provided this very good diagram. So here are the dimensions of the furnace. Here is the roof incline of 22 degrees. Now, the one thing not on the diagram is this information, the span of 36 feet. So that's this entire length here. So what can we do to find this missing length D? Well, I think we should look at the triangle here. Okay, so I'm going to begin by drawing that triangle on my page. And all my triangles, you'll note, are not to scale. They're very rough sketches. They are not in the correct proportions at all. But they're good enough, I think, for our purposes. So let me just pop this furnace in here. I'm going to say that this is the furnace. Okay, so here's the left side of this triangle. So we have 22 degrees here. We know that this length, just from here to here, is 6 feet. And that this height from here to here is 4.5 feet. And of course, we're looking for this value called D. The other thing is, if this whole thing is 36, then the length from here to here is half of that. It's 18. So this length here is 18 feet. Okay, so you can see again, it's not nearly to scale. I've said that this is 6 feet and yet this is 18. So it's not to scale at all. But as I said, it'll serve for our calculations just fine. Okay, so what can we do? Well, I think that if we have this angle and this whole side length here, we should be able to find this entire length here, which maybe we can call H. Okay, so the height H here is 4.5 plus D. So I'm going to call that side length H. So here's the angle. We are given the adjacent side. The adjacent side is 18. And we're going to find the opposite side length here, which I'm going to call H. Okay? So what can we use if we're talking about opposite and adjacent? This is tangent. So the tangent of 22 degrees is equal to the side length h, which, I mean, I could put an h, or I can call it d plus 4.5, right? The length of this side is d plus 4.5. Okay, so that's the opposite side length, d plus 4.5, and the adjacent side length is 18. So now we can go ahead and solve for d plus 4.5 using multiplication. So d plus 4.5 feet is 18 times the tangent of 22 degrees. So why don't we work out this quantity first of all? So 18 times the tangent of 22 is about 7.3. So 7.3 represents this height here in the picture. This whole height is 7.3. So what does that mean for D? Well, D then is the 7.3 minus the 4.5. Okay, so when you do that subtraction, you'll get 2.8. So D is 2.8 feet. Okay, so that's how we can solve that problem. And again, this is from your textbook on page 229, and it is problem 10. Okay, let me make sure all of that is visible for you. Okay, and again, I knew that this was 18 feet because it said that the width span was 36 feet. So we had the angle. We wanted to find the opposite side length, and we were given the adjacent side length. That's why we picked tangent. Okay, let's go on, sorry about that, and do the second part of today's lesson, which is finding an angle. Okay, so I'll put the book aside for now, and we'll get started. So we are still, of course, referring to our general triangle, which I might put right there at the top of our page to make it more useful. Okay, so we're still going to refer to this triangle, and we're going to try these problems where we're solving for an angle. So let's begin with this first one. We have side A is 12.5 and side B is 33.4. What are we finding? Angle B, which is this top angle up here, okay? All right, so which trig function should we use? Well, we want the one that doesn't include the hypotenuse because we weren't given the hypotenuse. So we're going to use tangent. So we're going to write the tangent of angle B is equal to, and we've got to make sure we put opposite over adjacent now. So this will be 33.4 divided by 12.5. Just like that. Now, when the angle is unknown and you're trying to find it, you're going to need your inverse trig function. So angle B is going to be the tangent inverse of this fraction. So I'm going to show you how you can punch this in your calculator all in one step. Okay, so you're going to start by displaying tangent inverse. So you do shift tangent. And then I'm actually going to use the fraction button here. This button, see, with the ABC. So I'm going to go 33.4, over 12.5. And this is the angle in degrees. And all I have to do now is round this correctly to the nearest 10. So this will be 69.5 degrees. Okay, and if you don't want to use the fraction button the way that I did there, you can do it like this. Shift, tangent, but now you'll need a bracket. 33.4 divided by 12.5. So that's another option for you as well. Okay, next one. Let's label side A, 53.1, side C, 89.2. Which angle are we interested in? The lower one, which is A. Which trig function will I use? This is the hypotenuse. If this is the angle, this side is called opposite, right? If we were finding angle B instead, the side would be called adjacent, okay? But since we're finding angle A, this side is opposite. So we want to use sine. So we write sine A is, we put the opposite side in the top and the hypotenuse underneath it. Okay, and then we use the inverse trig function. Okay, so you can watch on the calculator here. Shift sine 53.1 over 89.2. This is the angle in degrees. Rounding it to the nearest tenth, we will have 36.5 degrees. Next one, let's label. We have sides B and C, so here and here. Finding the lower angle, A. What are these sides called? Well, this one is always called the hypotenuse, regardless of which angle we're interested in. This one is adjacent to angle A. You see, it would be opposite angle B, but it is adjacent to A. So we are using an adjacent side and a hypotenuse, so we're using cosine. Cosine of A is 21.5 over 42.7. We're trying to find that angle in degrees, so this is how we know we're going to use the cosine inverse. Okay, so let's do this one. Shift cosine. See, it says cosine inverse 21.5 over 42.7. Okay, and round it to the nearest tenth, 59.8 degrees. Okay, I'm going to do a couple more problems together. So part D, and then one more question from your textbooks. So part D, let's first label the two given sides. And now we're going to label the angle of interest, which is down here. The given sides do not include the hypotenuse. So we know not to use sine, not to use cosine. We're going to use tangent, the tangent of angle A. So that's how we're getting started. We make sure that we put the opposite side on top. Which side is opposite angle A? Across from angle A, or opposite it, is 42.3. And underneath must go the side that is adjacent or next to angle A, and that is 63.4. Find the angle in degrees by using the inverse trig function. tangent inverse. I'll show you with the bracket again, just in case you like that better. So bracket 42.3 divided by 63.4. Close it. Okay, and that is your angle measure, 33.7 in degrees. All right, excellent. And now I'm going to open up the textbook so we can look at one more applied problem. So this is page 228, problem 8. All right, so let's have a look at that problem together now. Okay, so I think you can see that here. There is a diagram. It says, the loading ramp in this figure is 8 feet long. So you can see this is the loading ramp here, and is placed from the ground level to the top of a loading platform. The platform is 1.5 feet high, and that's indicated here, 1.5 feet. What is the angle A of incline? So they're showing angle A. Of course, that's this angle here. Okay, this lower angle here, formed between the ramp and the horizontal. Okay, so I think I'll start just by drawing that here so that it looks like our right triangle. All right, so we know the platform height, and it's 1.5 feet. We also know the ramp length, and it's 8 feet. We're trying to find the angle of incline, which is in here, which you could label theta. In this problem, though, they're calling it A. So angle A is in here, right? Okay, just like that. So we're trying to find the angle, and we're given 2 side lengths. We just need to make sure we pick the right trig function. So we have to know what we call these side lengths. This one here, 1.5, is opposite the angle. And this one here, 8, of course, is the hypotenuse. So we must choose the trig function that includes the O for opposite and the H for hypotenuse. And of course, that one is sine. Okay, so you can still see that at the top here, I think, right? Look. So we're going to use this one because it includes the opposite side and the hypotenuse. So we are writing, whoops, put our picture back. The sine of angle A is, now we have to make sure we put opposite on top of hypotenuse, like that. We are trying to figure out this angle length, angle size rather, in degrees. So we have to use the sine inverse, just like that. Okay, and we're going to use our calculator. Sine inverse 1.5 over 8, and then push equals. So this is the angle measure in degrees. And remember, we've been rounding all of these quantities to the 10th in this video. So we end up with an angle of inclination of 10.8 degrees. Okay, so thanks so much for watching this video. A reminder that we did 2 main things in the video. In the first half of the video, we looked at how we can find an unknown side length in a right triangle by using the correct trig function. And then in the second half of the video, we looked at how we could find an unknown angle in degrees by using the correct trig function. So I would really love for you to practice all of this. I've got a handout of problems which I have posted for you in Blackboard. So definitely try all of the questions on that handout. And in addition, I've picked out just a few word problems from your textbook for you to try as well. So please take the time to practice this, and if you have any questions, don't hesitate to send me an email message. Okay? Thanks so much. Have a great day.